Hi, everyone. Welcome to this week's Kafka live stream. We'll just give it a few minutes as people join. This is our regular 30-minute deep dive on a Kafka topic, simplified through the Lenses team and suite of solutions. And whilst we're just waiting for people to join, remember to connect to our Slack community. You can speak to the whole Lenses team and over 3,000 Kafka fans and experts. You can ask any question, you can get product updates, and you can also be informed of workshops and live streams such as this one. So maybe we'll paste a link to how to connect in the chat. Okay, and this week we are talking about how to get data from your Kafka environment into a security incident event management solution, or otherwise known as a SIEM. And we've got a really special guest with us today, an expert in security and operations and a lot of tooling around those domains. Hello, Olivier, longtime friend of the Lenses family. Maybe you want to introduce yourself.
Hello, everyone. Thank you, Guillaume, and thank you for the short introduction. I'm the co-owner of the Optimus companies. So we are, I would say, expert as is written in the security operation and data analytics, and we are really around the professional services-led type of company, loving the solutions such as Lenses or Kafka in general, but also doing Splunk and Cribl. Splunk being more on the analytics, security, and IT operations side. And Cribl we will just describe in a few minutes of what it will be. I guess there's no point presenting Lenses or Kafka to you.
Hopefully not. No. So as we're saying, we're talking about how you can integrate data from a security architecture based on Kafka into a security solution. Now, a lot of what we're going to show here today is around Splunk, but it doesn't necessarily have to be Splunk. So here the assumption is that your organization has decided that Kafka is a critical component of your security data architecture, and you've been asked to integrate data from Kafka into, let's say, Splunk. And just by the nature of this type of data, it tends to be highly unstructured. It comes at huge velocity because it's coming from a lot of security devices and network infrastructure. And as a result, it often needs to be filtered or transformed. And there's a few different reasons why you might need to do that, which we'll explain. Or in some cases, it needs to be routed downstream to different solutions. It's not just Splunk, but maybe it's Splunk for high value data, and then S3 for compliance reasons, just for audit to ensure that you have a full history of all your security logs at a lower cost. But there are a number of challenges with doing that and meeting those requirements. Olivier, maybe you want to touch on some of them.
Sure. Yes, we do see quite a lot of challenges, I would say, trying to get the data into different SIEM. And the main issue, I would say, it's related to a management decision just to get data from Kafka and putting there, and people treat it as a tick in the box and not thinking about how to consume the data. So I would say the most biggest issue I can see is zero or little visibility around what data exists in Kafka, because you have the people who are ingesting data into Kafka. So the producer of data are just producing and sending, and wouldn't really mind what it is being used for, and the consumers have no idea what to consume and what to check in Kafka, because there's so much data that is being said there. And therefore, it has really difficulties on trying to understand, what they should consume and which type of, topics they should consume in there. So that's kind of one of the biggest issues that I can see and experience as well, trying to consume data from Kafka. The second one I see is getting the resources from the Kafka platform team. They are very busy. So they are, their role is mainly to handle, I would say, the Kafka platform and ensuring, everything is good in performance. The problem I see very often is, me very often as consumer need their help to know what is available in Kafka and making sure, what, if I'm consuming, fast enough the data in Kafka. And the same problem happen from the producers, because they have to produce data, but they have to make sure that the data arrive in Kafka and ensuring everything is set correctly, because they're not Kafka expert most of the time, and therefore the Kafka team get busy as just administrating the developers and not administrating their own platform. The third part I see is a huge number of data. So we have a huge number of data. People use Kafka in those type of situation as a dump, where they put all sorts of data, things which probably doesn't make sense for any team, but is being pushed there, and different team not knowing what is available for them, and very often consuming the wrong type of data, or not knowing that data has changed topic when they're consuming it. And the last point I would say is really the type of data that is being put into Kafka for a theme type of solution is related to the unstructured way of the data. So trying to consume unstructured data is much more difficult than the usual Kafka data, which is structured data, and therefore we have to think about how to handle this type of data in a very specific way for each different type of theme we're using, it being Splunk, Elastic, CrowdStrike, really any type of consumers or any type of endpoint need the type of data in a specific way, which is usually overlooked when we're putting the data into Kafka.
Yeah. Okay. Very well put. I sympathize a lot with those pains. We're going to show and talk about three different ways of integrating, or three classic ways of integrating data from Kafka into your SIEM. The first one is just a straight data integration using Kafka Connect. In our case, we're going to be showing the Splunk connector developed by Splunk themselves. The second way is where we're going to still using Kafka Connect, but we're going to fully manage the connector and also pre-process the data through Lenses, the functionality within Lenses. And that's going to address that some of those challenges that Olivier talked about, the maybe filtering or restructuring or normalizing the data. And then we're going to show a third option, which is still using Lenses, but a lot of the processing is going to be developed or done by a technology called Cribl. It's hot in the security space right now. Olivier's an expert on it. And so we're going to show you that method too. So let's start with the really classic example where we are sourcing data from a series of producers. Maybe it's Firebeats or a series of different open source log collection technologies that's producing into Kafka. And then we're sending the data via Kafka Connect into downstream analytics solutions. Now, as I mentioned, we're heavily going to focus on Splunk here, and does Splunk have a Kafka connector? So the advantage of this pattern and this architecture is, in some way, it's kind of free, but nothing's really for free. I say free because the connector from Splunk is free, and Kafka Connect as an open source technology is free, but you might be using a commercial offering. And then the other advantage is that it's leveraging the same infrastructure that you're probably using for other use cases, for real-time analytics and so on, which is broadly Kafka Connect. So no major changes to your architecture. The disadvantage is that there'll be almost no fraud. There won't be any filtering as you send the data down to your solution, which might mean incurring a high cost or complexity downstream. You might want to route the data to different solutions. And in many cases, you need to parse or normalize the data before it hits that downstream solution to make it easier to consume. And as Olivier mentioned, as a consumer, as a team responsible for Kafka or for security, you actually need, it's really important you have visibility into what's happening upstream in Kafka. And as Olivier mentioned, often those centralized platform teams are just so busy servicing so many different teams that they don't have time to prioritize your requests. So you're left almost on your own or in the dark or having to wait. So before
I have
we...
to say, Guillaume, sorry,
Yeah.
just to let you know, I mean, one of the biggest pain point I see in this, environment is really the zero visibility. Not knowing if you're lagging, for example, it's excruciating because you're receiving data, but you have no idea if you're receiving, all the data or not. Or if you don't receive data, you have, no idea if it's because there is a problem with the connector or simply because the producer is not producing data. And it happens, from one of my customer, they realized that there was a problem 6 months after. that, they had a problem, which is again huge because they're losing like 6 months worth of security data. Again, nobody have noticed it, and this is, definitely terrible, for a security point of view. It is. So no visibility is definitely one of the big pain point on the security world.
Yeah. So here already in that, I'm going to cheat a little bit. Let's assume I am someone in the security team or in the Splunk team, and actually I've kind of already using Lenses, because the great thing about Lenses is addressing that visibility. So here, what I'm going to show you, this is our data, the data catalog. It lists all the data assets or topics within your Kafka estate, and we have one topic called audit D. Now, I should mention that this is an instance of Lenses and Kafka running locally on my laptop. It's what we call Lenses box that we often talk about on these live streams. So it's not production data yet. And I can quickly browse this topic, explore the messages, and we can see that there's firstly a huge number of messages, and there's a lot of data here. We have the raw event and a lot of that data also in separate fields. Now, we don't necessarily want to send all of this data to Splunk, but just for argument's sake, let's say we do. So we would use the Splunk Kafka Connect connector to send that down into Splunk. And in the case of this scenario here, I'm going to deploy this connector through Lenses. So let me go and select the Splunk connector, and I'll explain a little bit about what I'm doing in a second. But anyone familiar with Kafka Connect will be familiar with this key value pair parameters here. Let me just ensure I have a token into Splunk. There we go. Okay, so here we're using the Splunk connector developed by Splunk, and we're going to just simply send everything from that audit D topic into an index within Splunk called security. So let's go ahead and deploy that. And let's see, it seems to be running. Yeah, 3 running, 3. It's all healthy. Now let's have a look at Splunk and see what we see. So let's query that, and there, sure enough, we see data. Now, Olivier, what's the problem here?
Well, there's quite a few problems here. The first one is the amount of data that you are sending to Splunk. Because most of the time it is sent, you're paying either like for the license or the volume of data you are sending. And the second one is really the really interesting information that I need is the message. So the message is what I need, and I have a huge amount of information around the message, which I don't really need in security. So that's quite bad. And the third one, I mentioned two, but there is actually a third one which is extremely important. In Splunk, we need to have the data in a certain, I would say, not format, but I would say we do have some parsers which would understand this data automatically, because now we are sending the data in a different format. This is a JSON, wrapped around the message. All of my parsers wouldn't work out of the box with this, which means I need to spend time, and a huge amount of time, to make this like what we call SIEM compliant, Common Information Model compliant in Splunk, so that everything, every use case in security will work automatically. So that's, for me, great. I have the data, but very difficult for me to actually exploit the data.
Okay, great. So we can do better. So option 2, this is going to address these challenges. This is still using Kafka Connect. So we're still going to use a connector, except now we're going to extend what the functionality of Lenses by using Lenses to build a stream processing application with SQL. It's a great technology that we've introduced in Lenses. And what this is going to do is it's going to filter, normalize, process, or do any other sort of transformation before it hits the connector. And we're going to manage this application through Lenses. Now, here the advantages are still that you're not having to introduce or change your data infrastructure or introduce new technologies. You're going to be able to parse, filter, normalize the data to reduce costs, and also for it to be more efficient downstream within Splunk, as Olivier mentioned. And at the same time, you're going to have full visibility as a security team of what's happening upstream in Kafka through Lenses. So it's going to address that pressure that you have to put on that centralized platform engineering team. Now, the disadvantage, you could say, well, these applications to process the data are going to be based on SQL. And in some cases, that's not the easiest thing. It doesn't address all the use cases that you might need to do when it comes to processing unstructured data. So I'm going to show you what that looks like. But firstly, I just want to explain about the SQL capabilities within Lenses. If you're not familiar, there are two SQL engines. One, that we call SQL Snapshot. This is used for point-in-time investigation and troubleshooting. So I'm going to show you that in a few minutes, but it's great for quick analysis of data. And then that same SQL syntax can be translated into SQL Processor, which is a continuously running application that's going to read from a Kafka topic or one or more Kafka topics and rewrite to another Kafka topic. So this is perfect for that data transformation use case. And just a reminder that Lenses just sits on top of your existing data infrastructure. In the case of the SQL Snapshot, it's just going to immediately query the data in your Kafka topic or in the Kafka cluster. In the case of the stream processing, that it's going to deploy an application on your existing Kubernetes infrastructure. It's going to sit and live alongside your other microservices. And in terms of the connector that I deployed before, and I'm going to deploy another connector, that's just going to deploy the connector on your existing Kafka Connect cluster. So let's have a look. So firstly, let's just go to the topology just to show that somewhere down here, here's our original audit D topic, and it was sending down that connector to Splunk. So now what we're going to do is process that data. If I just go into it and I go to the data set, so this is and this time I'm going to go to the SQL Snapshot, SQL Studio. And this is, if you remember what I was saying, I'm just going to copy my search. This is my point-in-time query. And here I'm doing a select where I'm selecting some of the fields and renaming the fields because I need to rename them to normalize them to Splunk's to Splunk's format, and so that the technology add-ons within Splunk can be applied correctly. So if I just query that, we can see now we've got a raw field, which is what Splunk would expect. And we've got the important metadata fields within that Splunk expects: host, source, and source type.
And you've done some filtering as well, as you can see.
Sorry, whilst I was going to forget to say that. So importantly, we're also filtering just to one agent. Now, this could be a WAF device or some sort of network device and so on. So I've really limited the amount of information that I'm going to send to Splunk. Now, this is a basic SQL command, but as you can imagine, almost the full capabilities of ANSI SQL are available here. So you could do joins and aggregations and so on. The point is here, I haven't actually transformed the data yet. I'm just querying for my investigation. And this looks good to me. Now I want to go to the next step and have it continuously transform that in a stream. So I'm going to convert it in a stream processing application, what we call a SQL processor. And I've prepared this in advance, so you're not having to watch me type. But effectively, this is the same query that we had before, except this time we're adding a condition saying, well, insert the output of this is going to be an insert into a new topic called audit defiltered. And I'm just going to give it a name. And behind the scenes, Lenses is going to deploy this application as a stream processing application on your Kubernetes cluster. And you get a nice visualization of the transformation that's happening. It's very basic: reading from one topic, filtering, writing to another topic. So this is the source topic. This is the output topic. And if we have a look now here, in fact, sorry, I should have clicked back and just show that, where is it, monitor. We can see that it's already processing hundreds of events. So now let's go into this audit D topic. And now we can see it's nicely formatted. It's in a state that's ready to be sent into Splunk. And I'm not forgetting anything here, Olivier, right?
Yeah, I guess it's just about sending it now.
Okay, let's send it. So I'm going to this time deploy a second connector. Let me see. And create connector. Select Splunk. we go. And this is similar configuration. Let's make sure the token is there. This.
And yeah, and just so you know, we don't need actually to set this second connector. So with advanced configuration here, we could have just one connector and decide, where things are going. But just for simplicity of the demo, we thought it would be just easier to just show you with two connectors so that you have a visible way of, sending the data to another index here. But potentially you could do it with one single connector as well.
Yeah, exactly. So here we're going to send it to a different index within Splunk called Splunk security fill. I think we're all good. Let's go ahead and deploy that. And let's just double check. So now, yeah, here are two connectors, three tasks. They seem to be running. If I go to the topology view, let's just have a look down here. There we go. So here's our pipeline. The original source topic, that was the original connector, but now we've put in the middle a stream processing application that's writing back to Kafka and then out into that second connector. And let's just switch and go to our second filtered. There we go. And hopefully we should see some data. Yeah, we do. Okay. So maybe you want to explain this now. What's the difference?
I mean, yeah, you can see here it's much more concise, and what it was interesting for me is the messages. So you can see is exactly what I need in a security world. All the, I would almost call it the fluff around, the where the data came from and so on. For my specific use case, I didn't need, and therefore, I could just streamline as it is. Now with again filtered data, so I don't need to send the whole set of data. I can send only what is important to me. Therefore, saving disk space, licenses, and also in processing power, because I'm querying less data every time I'm searching for my data.
Yeah. Okay. So great. Now, what do we want to? What's what you might other problem might you have, Olivier?
Yeah, I mean, this is great. So again, for this type of use cases, it works perfectly well. One thing I've noticed is if the filter of the data is much more complex, or if you need to change the data, for example, anonymizing the data or making the data not, visible by some person and visible by others, and so on and so on. So when you have really complex set of data, it's a much easy, much more difficult way you would do with the SQL processor. The same way you will have to create, an application, from a Java or a similar language to, process a very complex set of data. You will have here the same problem. And one thing we're using quite a lot is a kind of different software called Cribl. And that's what we will just demo you instead of creating an app, which could take you, quite a bit of time. We as, like Optimus, we're using quite a lot of Cribl because we're working outside of Kafka as well. And this is what we want to show you. So Cribl is simply just a software which is here, which is managing, security and IT, type of data, and consume the data from any type of, I would say, with the sources, and sending it to any type of destination in this. And one of the sources here being at Kafka level, where we can consume the data from Kafka, modify it the way we want it, and then push it in a specific format to these different different endpoints, and here different SIEM that we have here. So again, biggest advantage here is be able to process the way we want it for each different solution, different SIEM. A very complex processing. We can route it to any type of destination or almost any type of destination, and using it combining with lenses will have all the advantages with lenses, meaning having all the visibilities that we have with lenses. So knowing which type of data we have in Kafka, be able to search with a different tag, having the visibility of how we are consuming from Cribl, and so on. So all the advantage you have here, we can map it and contribute it with Cribl, so that we have the full visibility end to end, and putting data into these different themes that we have. Of course, this small inconvenience that we would have is the the way that you need to add another tech stack in your environment, which is Cribl. But believe me, like having worked with Cribl for quite a while, it probably is worthwhile. And what we want to do here is transform again this big block of data on something which is very, very easy. Even what you see on the right hand side would be much better than this. But we try to oversimplify it here so that you can understand. But let me do a demo and let me share my desktop, and you probably see how good this could be in very complex environment. So this is Lenses. I'm probably showing you how it looks like. So hopefully you can see my desktop here. So it's presenting like this. Again, it's a very simple environment running on my desktop. You will have here the type of data that you can get. So a lot of different type. That's just a configure only. A lot of different type of data you can consume from. And the same thing here over here is a lot of destination you can send to. So we just selected a few of the data that you want. And just so we can demo you something, we have our the Kafka environment, which is already configured with this ODD topic. And what I can do is sending into the dev node so that I can play it. So at the moment, I just do a pass through. So just to see how the data is, I can capture the data. This is the live data that I'm capturing. So you can see here live data coming on. So you're probably familiar with this type of data here. I'm happy with it. I can save it as a sample file. So great, I'm saving it now. And let's now work. When I say work is, play around with the data. So you can see here, I have a lot of pipelines. Pipelines is really the equivalent of the stream processor you would have in Lenses. So we have here the pipelines, which looks like this, and we have here our capture that we've just done that is visible here. So this is the raw data in, and this is what we'll do out, and we can create some different functions. So we have like here a rename function, which just rename the different field into different, different values. So I can click save just to see how it looks like, and you will see here in a few seconds. There we go. It starts to rename the data as it is. I can do the autofill extraction. So this is very powerful because you can have different, hosts that can generate different timestamp, and you can play around with it. Very, very complex way of dealing with the, timestamp as well. So great way of doing it. And again, I can, do some evaluation as well in it. So you can see here, I'm setting here some, static fields, and I can remove some of those which I don't need anymore as well. So which is quite great. Again, I can save it just to show you how it is, changing, almost in real time. And I can play with it. I can flatten the data. So this is great if I want to have, avoid having multi-level type of fields, because Splunk doesn't like as a metadata multi-level type of fields. So here I'm flattening up the data, the JSON. I'm filtering the data as well. So I can filter the data, and the filter data can be absolutely anything. So I can do some regex extraction. I can drop the data. I can say here, if the path is the type equal path, I want to get rid of it, and the path is what I'm extracting here in this particular area over here, which is a type. So that's what I'm setting here. And you can see here is just got rid of this, event, and I can go down, and you can see here some of them hasn't been, deleted in this one. So again, this is just my sample data I'm working on, so I can, make sure the data looks good. And then finally, I can see here, I can remove some, like zero value as well. So this is one thing I love as well. So when I get some zero values, there's no point. I'm just do some parsing of the data that looks in a specific way, and then I'm reserializing the data, and I'm setting here, remove anything that I don't like into this. So in this particular one here, I'm saying if you have any value which is equals to 0, just delete it. I don't want to see the something equals 0. I just want you to remove anything, because 0 doesn't make any sense in this type of data, of course. So once I have this, you can go much more complex as well. So this is an example of code that I won't use here, but you could use some, like JavaScript code as well to the one which is even more complex. So this one is, for example, transforming a hex type of data into a, like a human readable type of, value. And this is quite nice because you can set it per field as well inside your raw data. So you can really go in advance. So once I have this is quite great, and I can go very quickly in the quick connect. I'm happy with this. So what I'll do is I will just go here, delete what I had before. putting into the dev new, and I can now push this into, I can here, there we go. Push this into Splunk directly, use the pipeline I've just set. So here, this is a to Splunk one, and then save it. And from now on, here we go. This is going into my Splunk. So I can show you very quickly how it looks like in Splunk. So here I have my advanced data. So let's see if I have data there yet. Takes probably a few seconds so that it is applied yet. I could use the all-time real-time, so show me the data as soon as it arrives in a system. Just reminding you how the data, oops, let's go to delete one. I don't want to delete, of course, the data, showing you how the data looks like before. So you have here the raw data in Splunk. This is what was transformed by, by Lenses earlier. And what I can see, hopefully this is going there. And it is not going. I probably done a little mistake here in mine. Yep. Let me see if I done the correct index. And let me see. Yep. Yep. The issue here. So this can be cut. Yep. So let me see how the data looks like in Splunk. So you can see here the advanced data, and you can see now how the data looks like. And this is exactly how Splunk would actually, get the data. So when you're collecting the data with this Splunk software, which is called a universal forwarder, the agent of Splunk, the data would look exactly like this in Splunk. And here I managed to transform the data exactly the way I want it without losing any data. You can see here on the side, I still have all the metadata that I had before, except that it is in metadata. So I haven't lost any data. So if this is still important for me in terms of not losing any data, because just in case, might not be useful in the security world, and indeed for this specific type of data is not useful, but maybe for another team in terms of IT operation, this could be important, knowing about the file-based version which is being sent, so that I can again gather the data. Splunk is great for having the same set of data being useful for different teams. And here I managed to get, these different set of data very easily into Splunk, and, keeping all the information, while it becomes for the security team very easy to compute now the data, because it looks exactly the way that Splunk would get it. And all my, what we call technology add-on, my parsing, script would work out of the box with this set of data.
Nice. Yeah. Fantastic.